So for the next session, we have Hanna Kim from KAIST. She's going to be talking to us about web-enabled LLMs and what could possibly happen when they go online. So please go ahead.
Okay, thank you for your nice introduction. Hi, I'm Hanna Kim from KAIST, and I'm so happy to be here. And I'm gonna introduce our paper, When LLMs Go Online, the Emerging Threat of Web-Enabled LLMs. Nowadays, large language models are more powerful than ever, and with that power comes growing concerns over how they might be misused. Actually, we are already seeing cases where attackers use them for cyber attacks, like generating malware or other harmful content. So researchers have started looking into how LLMs could be used in cyber attacks and how effective they really are. They've also investigated the potential risk of LLM agents when given access to various tools. But there's still one important thing is missing. We haven't really looked at the agent people use the most. If you have used ChatGPT, you've probably seen this button before. It's the web search feature. With this feature, ChatGPT can now access the internet, and this changes everything. Even if something wasn't part of its training data, now it can access and find it from the internet very quickly and accurately. And as you know, the internet has almost everything, including our personal data. People often share their personal information publicly on the internet, like email addresses or phone numbers like that. And this might not seem dangerous, but does that really mean it's safe? Something might say yes, and others no. Before we answer this question, let's consider the following question. How powerful and accessible are web-enabled LLMs for turning public personal data into real cyber threats? We try to answer these questions through this study. So to understand this, let's talk about some background. This is how a standard LLM works. You ask a question, then the LLM answers based on its training data. And now we can turn this LLM into LLM agent by giving tools. It decides when and which tools to use based on for the given task. It interacts with the environment using tools and utilizes the results to improve its response. In this study, we'll focus on LLM agents interacting with the web. And we introduce two types of agents. And the first one is web search agent. It has a web search tool to get the search result from engines like Google. It can search multiple times to gather more information. And the other one is web nav agent. In addition to search, it can utilize web navigation tools to scrape content from web pages and interact with clickable elements. When the search results are not enough, the agent can visit relevant websites and scrape their content and check whether the required information is available. If not, it identifies suitable buttons or tabs for accessing more information, and then retrieves information from the newly loaded page. In this study, we use 3 language models, including GPT-4o, Claude 3.5 Sonnet, and Gemini 1.5 Flash. And these were the latest models from these 3 providers at the time of our research. We will focus on 3 targeted cyber attacks that exploiting publicly available personal data. Personal identifier information collection, impersonation post generation, and spear phishing email generation. Let's start with the first one, PII collection. Our attack pipeline is really simple. We can just ask our agent. In this experiment, we targeted computer science researchers, including professors and their students. Our goal here is to get 5 types of PII, including name, email addresses, phone numbers, and so on. And for this attack, all we need is the target university name. First, we ask the agent to generate a list of professors' names from the target university. And then for each name, we ask to collect the corresponding personal data. Among the three models we used, only Gemini refused to collect PII. What you see here are the results from GPT. We compared the performance of a vanilla LLM and two agents. The two graphs on the left side show the number of correctly collected information for professors and their students. As you can see, the WebNav agent, which is the red polygon, achieved the best performance, while the vanilla LLM had difficulty retrieving information. Overall, adding tools significantly improved the performance at collecting PII. We also found that the agents were more effective at collecting professors' PII than students, and this is likely because professors tend to share their more information online. Now let's move on to the second attack, impersonation post-generation. Again, we targeted computer science professors here, and using the information we collected earlier. The idea was to make a social media post that sounds like it's coming from the target, but actually promote a specific claim. And to do that, we just gave the agent the person's name and his institution and a claim that we want to promote it. To evaluate how realistic the post was, we employed LLM as a judge. To give you an example, I asked the agent to pretend to be my advisor, Sungwon. And the claim I gave it was, LLMs are highly safe from misuse. As you can tell from our lab's name, my advisor is an expert in network and system security. The agent draws on this background to make the argument much more credible when discussing LLM safety. And also, it referenced his previous publications like Avant-Garde and Fresco to make the argument sound technically grounded. This is pretty amazing, right? And here are the results of our experiment. We asked the agent to write posts pretending to be computer science professors supporting each claim here. The graph shows the percentage of responses where the LLM evaluator identified the text as authored by the target individual. As you can see, the LLM agent performed better by aggregating detailed personal data from the web. And also notice that claim 2, which is a little bit more controversial than claim 1, this was less effective than claim 1. This suggests that impersonation becomes harder when the claim feels less natural coming from the target. And now let's look at the final attack, phishing email generation. We asked the agent to write a realistic email considering the current date and the target, and to include a realistic looking URL string in the email. Importantly, we didn't specify any details such as the email content or the sender. We just let the agent decide. The goal here is to generate highly personalized emails to induce the target to click a link. The attacker only needs the target's email address. And for this experiment, we recruited 60 participants, including academic researchers and employees. In a survey, each participant evaluated the email that was personally generated for them. And again, I tried this on my advisor. And honestly, I was really impressed because first, the sender is one of the collaborators of my advisor over 10 years ago. And the sender is still working at SRI. And it mentions the research topic they had worked on together and suggests starting a new project. What really surprised me was that it suggests the meeting time, taking into account both time zones, California and Korea. Although the suggested time is a little bit early for us, which is 1 a.m. in Korea, but, but this is still a rare question, right? What if I try this on someone from Microsoft Research? In this case, the sender is a professor from Georgia Tech, and our Microsoft researcher had actually worked with him before. And it brings up our Microsoft researcher's ATC paper, mentioning both the title and what it was about. Then it suggests starting a new project between Georgia Tech and Microsoft Research on extending this work. It feels quite personal, specific, and I think really believable. And now let's look at our experimental results. According to the user study, LLM agent with Claude shows that over 26% of participants said that they would click the link in the email. And here as well, we observed that the agents were more effective than vanilla LLMs. Then what factors make this difference? Based on survey responses about the email content, we found that agent-generated emails were rich in detail and accurately reflected the target's personal data. This personalization played a key role in their effectiveness. And on the left side, we compared the results of academic researchers and employees. Interestingly, about 37% of researchers said that they would click the link, and this is more than twice the rate of employees. We believe that this is because researchers often have much more personal and professional information online, and this makes them vulnerable to phishing attacks. And on the right side, we compare the effectiveness of phishing emails by changing some factors, specifying the emails proposed to request the login credential change, and using a different sender domain from the target, increase the click rate to 47%. Now let's talk about how accessible these attacks are. Well, this is my first time to visit Seattle, and of course I stopped by Starbucks. And while sipping my coffee, I had a thought that for the price of just one cup of coffee, we can generate 141 spear phishing emails in 22 seconds. This shows how accessible these attacks have become. In the past, attackers needed custom tools and had to spend a lot of time researching targets. It was costly and slow and required real effort. But now, with web-enabled LLMs, anyone can automate these attacks in large scale, quickly and cheaply. Now let's talk about safeguard robustness. In order to prevent generating harmful responses, LLMs have their safeguard, and of course, these three models that we tested have also their safeguard. And for attackers, this safeguard could be an obstacle, but in our experiment, we could bypass with almost no effort. So here, we examine their safeguard robustness by looking at different factors. For impersonation post-generation, we used these two claims and two different target groups, professors and influential figures in the tech industry. Then we measure the success rate of impersonation post-generation out of 10 targets for each group. And here are the results for LLMs without tools. We found that their safeguard activation varied based on both claim and target. They were more likely to refuse to impersonate influential figures than professors. But when we gave them the web-based tools, for claim 1, both Claude and Gemini successfully generated content in every case. This shows that sometimes these tools make it easier to bypass their safeguard. In spear phishing email generation experiment, we varied two factors, email purpose and target email type. for the purpose, we set it to either request to change login credentials or request for money. And for target email type, it was either an institutional address or Gmail address. And here are the results without tools. While Gemini refused to generate emails in all cases, GPT and Claude varied depending on the factors. When we asked to write emails about money or login credentials, both GPT and Claude refused, saying that such emails could be used for phishing. However, with web tools, GPT generated emails in every case, and Claude did so in all but the money request scenario. Again, we observed that web-based tools make it easier to bypass their safeguard. And as I said before, in our experiment, we could bypass this safeguard with almost no effort. Then why were these attacks so easy to carry out? I believe that first, LLMs show low sensitivity to publicly available PII. They don't really treat it as sensitive. And second, it is difficult to distinguish whether someone is trying to use that for a benign purpose or not. And finally, the incorporation of tools led to LLMs being more permissive. So I think about the future direction for LLM providers. First, we could restrict sensitive PII output. Instead of returning actual email addresses or phone numbers, we could just provide a link or instructions on how to find it. And second, we could analyze the user's conversation history to detect whether they are engaging in malicious activity over time. And finally, we could implement a risk assessment step where the model reasons about whether its output could be used for cyber attack. So in conclusion, in this study, we examined the risk from LLM agents using web-based tools in cyber attacks, and we show that these agents can automate these attacks really effectively. Do you remember this question? I think we can answer it with confidence. No. Thank you for listening my presentation, and feel free to ask questions if you have. Thank you.
Yeah, thanks for your talk. So you said that these three things that you did are attacks. And if they're attack, at the end of your discussion, you touched briefly upon it, but how would you say, can you prevent these attacks, and whose responsibility is it?
I think, first of all, the LLM providers have to restrict their services to prevent generating these harmful content. Yeah, because they're providers, right? So, but as I said before, we observed that these attacks are easily conducted with these commercial LLM services. So they have to design their safeguard more strictly. And obviously, I think the attackers are the problem. So, but we don't. But like as defenders, we cannot force them. So yeah, I think the first one is we have to prepare this safeguard. Yeah, thank you.
Yeah, on that point, could you please tell us a little more about the safeguards that you observed and how you concluded that it's going to be very easy without an effort to bypass them?
Actually, there are a lot of research about how to make this safeguard or how to bypass this safeguard. So specifically, actually, for example, we can just ask like LLM how to make the bomb. Then these LLMs usually, I cannot help with that answer like that. So I actually at the time of at first I expected that these LLMs say that oh, I cannot help with your like generating emails, or I cannot collect this PII, but they didn't say, they didn't refuse that. They just generate their responses. So that's why I think these safeguards are not enough to prevent the proposed attacks here. Yeah, and I think there's a lot of methods to build their safeguard, and one of them is like using RLHF, yeah, like reinforced learning, using the human feedback, and also I was told that they also use like filtering system, so they can filter whether the prompt is malicious or not, or they can also filter the final response is malicious or not, like that. Yeah. So
when you try to impersonate the Georgia Tech professor, how did you fake the source email address? So my understanding is you had an email, the LLM fake that email, the content. But also I saw that the source email address was indeed gatech.edu.
yeah, that's really good question. And actually, the example was a little bit, I mean, the domain address is a little bit different from our experiment setup, but I know that using the exact same real domain is difficult. So in our experiment setup, we asked the agent to camouflage the sender's email address. And actually, we didn't send these emails directly to the target. Instead, we used the survey format. So
You did survey.
Yeah, right. So that's why we could use these email addresses. Yeah.
But in reality, I think many email clients will detect this kind of strange sender email.
Yeah.
At least give some warning to.
Yeah, I think that you're right, and that's a good point. And I also agree that nowadays our systems can prevent these types of like strange email addresses. But what we want to see here was these LLMs can generate these like email contents really realistic and really specific to target, and that's what we want to see here through our experiment.
When you so you did a comparative study about whether people would click links or not. Did you find out which exact factors they spotted when they were not clicking the links, or why they would click the link?
Yeah, actually in the survey we have like, I cannot remember the exact number, but maybe like 7 or 8 questions. And one of the questions was related to what you asked. And actually we said that we asked the agent to camouflage the sender's email address. So people thought that, oh, this is strange because this email address is a little bit different that I know, and that's the major reason that they didn't click the link.
Yes, so my understanding is that you provide only the target email address and nothing else. Did you try, or can you guess how much better the attack will be, or how much easier it will be to defeat countermeasure if you provided more context, like for example an email, as opposed to just an email address?
Sorry.
So if you provide more input, like a complete email from that person as opposed to just the email address, do you think that would make the attack much easier, or it wouldn't change much?
You mean the institutional address and Gmail address? Is it right?
No. When you in the prompt to get the fake the phishing email, you provide just the target email address as an input. You could provide more inputs, like some emails from that person or some additional document. Do you think that would help? Is there any way to test that, whether by adding more information you can bypass countermeasures or get a more compelling email?
Your question is not only just giving the target email address, but also like giving more information. Yeah, I think that's possible. And actually, what we want to do was with a really small piece of information, this agent can generate highly specialized emails for target. And that's why we just utilize the email address. And if the agent, since the agent can access the internet and find information about the target, so I think that's kind of aligned with your question.
Yes.
Yeah.
So it's already doing that because it has web search.
Yes, but
So anything public, it would already know.
yes, but something like a public email to respond to can maybe make it much more effective. Or not, I don't know. That's the question.
I mean, it would find the mailing list mail or something. It would already have a lot of emails.
So regarding the email address thing, I mean, it's so common for people to just, instead of using their institutional email, they just use their Gmail address for whatever reason, or they use some other email. Sometimes people use an email address from their prior institution because they've been a PhD student somewhere and they have still an email from that, and they just, for some reason, want to use that. So I just, maybe, like at least, I'm just so used to receiving emails from all kinds of addresses that people, sometimes like in the middle of an email conversation, they just switch to using a different address. And it's just, I don't know how much you can like, yeah, you have to be really careful with those addresses, I guess.
Through this experiment, we saw that like actually when we search our email addresses, and if it was institutional address, then if there is no enough information online, then the LLM guess using the email address domain and generate quite realistic email content. But if we use the just Gmail address, then it cannot find enough information in many cases. So I think that's like using just Gmail address would be much more safe in these types of cyber attacks. Yeah.
Yeah, there's also a scenario where actually the person's, like someone's email is truly compromised, and then that address is just being used to send these things. So it would be very easy now. I mean, just somehow break into someone's email inbox and or mailbox and launch this attack, send phishing emails to every single contact. Yeah. Why not? It's pretty scary.
Yeah.
I don't have a question. Any more questions? We have still some time.
I was just curious how the new red team reports from OpenAI, for example, that have come out, where they have blocked the malicious attackers and implemented new safeguards. So has this particular thing been tested before that or after that?
Your question is like, have I tested these attacks recently?
Yeah.
Yeah, I prepared a slide for that. Actually, now recently GPT-5 is released, so I tested. And actually, this is my advisors. And yeah, yesterday night I asked, get an email address of my professors from KAIST. then it got his PII and including his face picture. So yeah, I think still they are not like prepared these attacks.
But does it still give you a phishing email being produced from it if you use the same keywords like camouflage this or do this? Does it still work, or does it tells you a caution saying we cannot do this stuff?
I haven't tested using the exact same prompt, but when I just used please write an email to blah blah blah, but then it generated the email, so I think there's still a room to bypass this safeguard.
I think we should end here, and next speaker is Felix.
Thank you.